Hello everyone, this is Dr. Ashok Kumar from Government Women Engineering College Ajmer. In this lecture, I am going to discuss about the overview of smart antennas. The following contents will be addressed during the lecture. The need of smart antennas, smart antenna analogy, principle of smart antenna system, smart antenna configuration, switched beam configuration, adaptive antenna approach, adaptive beamforming technique, smart antenna benefits and drawbacks. The content of this lecture has been taken from these two books, which is written by the C.A. Balanis, and these books are very famous and popular across the globe. What is the need of smart antennas? In the wireless communication system, some unique challenges presented in opposition to their wireline counterparts, and these challenges are the limited allocated spectrum results in a limit the capacity of the system, the radio propagation environment, and the mobility of users give rise to increased fading and spreading in time, space, and frequency. The limited battery life at the mobile device causes power constraint, cope with interference due to the frequency reuse concept. These are the four challenges which we have identified in the wireless communication systems. So, various researcher efforts are investigating to increase the technology performance over the past few years, because the wireless communication experiencing the rapid growth in broadband wireless communication technology, especially in internet services and cellular systems. Among these, the researchers are working on different techniques, especially multiple access schemes, channel coding schemes, equalization schemes, and smart antenna employment. These are the four techniques that can be used in wireless communication systems. Here we are going to discuss about the smart antenna employment. The commercial solution of smart antenna technique is a good promise to the evaluation of aforementioned wireless communication impairments. So, we can understand the analogy between smart antenna technology and human technology. I mean human analogy. In this figure, you can see that there are two users. One we have termed as desired speaker, and other one is the undesired unwanted speaker, and these two users are located in a dark room, or we can say where the voice of the speaker arrives at each acoustic sensor, and the acoustic sensor is ear in that case, but these information come from these two users with different time delays, or we can say with different times. So the human, I mean, we can called as a signal processor, and this is the brain that compute the direction of speaker from the time differences or delay received by the two ears. Afterwards, the brain add these two signal strength for each ear so as to focus on sound of computed direction. So we can understand, or we can summarize this concept by the direction of arrival of the sound by utilizing a three-stage process, And in three-stage process, we can say once ear act as a acoustic sensors and received the signal. Because of the separation between the ears, each ear received the signals with different time delay. The human brain, a specialized signal processor, does a large number of calculations to correlate information and compute the location of received sound. This human analogy can be understood in smart antenna analogy. In smart antenna analogy, we can represent a equivalent smart antenna systems work at the same way using two antennas instead of two ears. In human analogy, we are uh, consider two ears, I mean two different users, but in the case of smart antenna, we are using two different antennas and a digital signal processor, and this is the digital signal processor instead of the brain, as you can see in figure 2. In smart antenna analogy, it has the digital signal processing capability along with the antennas, which makes the system smart. Digital signal processor measures the time delays for each antenna. It computes the direction of arrival of signal of interest. This is important in the case of smart antenna, that it will compute the direction of arrival of signal of strength, then it adjusts the weight, gain and phase of the signals to produce a radiation pattern and focus on signal of interest. I mean through by using weighting factor and by using the digital signal processing approach, we can achieve, or we can change, or we can adjust the gain and phase of the signal to produce the signal of interest, and while tuning out the interference or signal not of interest in the smart antenna system. So we can say that when we are transferring the same idea, into the mobile communication systems, then a base station plays the role of the listener, and the active cellular telephone simulate the role of several sound heard by the human ears. And we can understand how, or we can understand the principle of smart antenna system. So in this system you can see this is the human, and by using through the brain we can understand what information we have received, which information having the signal strength higher than the other one, and you can correlate this system to the control unit. Here this is the control unit you can see, and this is the RF input and output system, and this is the antenna element system. So through the antenna element systems and using the digital signal processing unit, you can achieve the steerable lobes. This is the important thing which we can understand in the case of smart antenna system. A digital signal processor located at the base stations works in the conjunction with the antenna array and is responsible for adjusting various system parameters to filter out any interference or signal not of interest while enhancing desired communication or signal of interest. Thus, the system makes the radiation pattern in an adaptive manner, respond dynamically to the signal environment and its alteration. So you can see from this figure that we have achieved the stable lobe from this smart antenna system. In that case, one thing is optimize from this figure that this is the beam forming. So principle of the beam forming can be understood, and it beam forming is a essential in the case of smart antenna system to weight the transmitted signals in such a way that the receiver obtain a constructive superposition of different signal parts. Here you can see the concept of beam forming, uh, especially the adaptive beam forming. Here you can see that there are different base stations that are located on a cluster, and the radiation pattern generated by these base station are represented by this one. And here you can see that this is the desired signal and these are the interference levels. When we are using at the receiving end, in that case the signals by each base station is received in the received, and we have multiplied with the beamformer weights, and we have add all the components, then we will get the signal output. And this signal output, I mean the radiation pattern, it adjusted as per the mobile or as per the user requirement. If the user is moved, in that case the radiation pattern, I mean main lobe, is also changes as per the user moves. So we can classify the smart antenna configuration in two major categories. First is the switched beam. In switched beam, a finite number of the elements are fixed, predefined patterns, and combining strategies or sector, we can say. But in the case of adaptive antenna configuration, a theoretically infinite number of patterns scenario based that are adjusted in real time according to the special change of signal of interest and signal not of interest. So the important is here is that in the case of adaptive approach, there is no need of predefined patterns, and we can adjust their radiation pattern, or we can say it's a man lobe in real time as per the requirement of the user. Here you can see the coverage pattern of the switched beam and adaptive array antenna system, and this system we have defined or we have compared according to the conventional sectorization. As you can see from the wireless communication that to increase the system capacity, especially in mobile communication, then sectoring is required, or we can say to enhance the capacity of the system, because the number of users are increasing day to day. In that case we are using some techniques through which we can enhance the system coverage, in which the first technique is the switched beam technique and second one is the sectorized system. In in the first techniques, I mean, sorry, in the first technique, the cell splitting is the important, and where we can congest, we have converted the main cell into the smaller cell, or we can say in a micro cell. So the height of the antenna is also reduced, and the transmitter power. The cell splitting is improves the system capacity by decreasing the cell radius and keeping the D by R ratio is unchanged, where D is the distance between the center of the cluster. But the disadvantage of cell splitting is the cost, and required a new base station. So the sectorized systems we can use to enhance the system capacity. Here we have sector is particular cell into three sectors, especially 120-degree each. So cell sectoring and cell splitting are the two techniques that can be used in wireless communication to enhance the capacity of the systems. But in the case of smart antenna, we have understand the concept of switched beam and adaptive beam. You can see from these two figures when we have compared with some important characteristics, and these characteristics are low interference environment. In that case, where the switched beam provides the significant gain over conventional sectorized system, but adaptive array provides significant gains of conventional sectorized system. At a significant interference environment, it is less effective, but in the adaptive array is more effective. As you can see uh, from this figure, significant interference environment, the adaptive is more effective and this provides the wide coverage area than the switched beam antenna system. Interference rejection capability is low in the case of switched beam but high in the case of adaptive array system. Coverage area is less and coverage area is more in the case of, you can see from this figure, the coverage area is high, low, and we have compared with the conventional sectorized, then very small in the case of, but in the case of adaptive we can enhance the coverage area of the system. Penetration level is low and penetration level is high in the case of adaptive array. So we have compared the switched beam and adaptive beam patterns. Here you can see the beam forming lobes and nulls that are switched beam left. This is the switched strategy and this is the adaptive strategy. In that case, we might choose the identical users, and this is the user we can say, and in this we can say this is user, and the co-channel interferers are represented by the dark line you can see from these two strategies. The switch fixed beam achieve quotient pattern control. In switched beam, the interference signal give at place of lower intensity outside the main lobe. So you can see this is the main lobe, but the interference are also providing the low intensity signal to the mobile user. But in the case of adaptive system, the adaptive strategy is more accurate or prominent and providing great signal enhancement, as you can see from this figure. In adaptive system, the main signal receive maximum signal enhancement and reduce the interfering signal, or we can say suppress the interfering signal. You can see, so this is the interfering signals, as you can see having the null, and this is the main lobe in the case of adaptive. So the comparison between switched beam and adaptive array, you can see that the adaptive strategy is more helpful or more popular strategy that can be used in the mobile communication or cellular communication. You can also understand the switched beam antennas, how the antennas is radiated. So you can see from this figure that in switched beam the radiation, or we can say beam pattern, is predefined. In that case, if the mobile user moves from location 1 to location 2, then the mobile is received or change the another uh, beam as the mobile moves from one location to the another location. And in this switched beam antennas, we are using a simple switching function, and that the beam gives the strongest signal as the mobile moves. But in the case of adaptive antenna approach, you can see the adaptive antenna average coverage is main lobe extending towards the user with nulls directed towards the co-channel interferers. So we can say that the adaptive approach having the ability to adapt in time the radiation pattern of the RF signal environment, or we can say the main lobe is the pilot signal or signal of interest, which suppressing the antenna in the direction of the interference or signal not of interest. So the adaptive array system can customize an appropriate radiation pattern for each individual users. So we can understand when the mobile user moves from this location to another location, in that case the pattern is shifted, or moves from according to the user location in a same cell, as we have discussed in this lecture. Further, we can understand the some beam forming techniques in which we are taking two adaptive spatial processing supporting two users, user 1 and user 2, on the same conventional channel simultaneously in the same channel, first strategy and second strategy. And this is the second strategy, this is the first strategy. So what is the difference between first and second strategies in adaptive beamforming technique? The first strategy is based on the part of the desired signal is already known through the use of training sequences, but second strategy, the direction of arrival from all sources transmitting signal to the array antenna are first identified. This is the non signal is compared with the what signal we have received, and then adjust the minimize the mean square error between the previous and received signal. In other strategy, the complex weights are then adjusted to produce a maximum towards the desired angle and null towards the interfering angle. So in first strategy, the beam patterns can be adjusted to null the interference. Since the weights are updated to the incoming signal, not only interference is reduced but the multipath fading is also mitigated in the case of first strategy. But in the case of second strategy, there are too many direction of arrivals due to the multipath, and the algorithm are more likely to fail in properly detecting them. This approach is optimize the signal to interference ratio SIR and is applicable to non-line of sight environment, especially in the dense populated areas, and this is more likely to occur in a and LOS environment where there are many local scatters close to the users and the base station, thus resulting in a wider spread of the angle of arrival. So in a summary, we have defined the different smart antenna concept. Here you can see this is the switched lob techniques, and when the mobile user is located at location X, then the blue arrow is represented the signal of interest, and the red is represent signal of non-interest, or we can say it's a interference. When the mobile user is moved, then the fixed beams uh, is switched from one beam to the another beam. In dynamically phased array concept, you can see uh, this is the main lobe as the mobile is located at location end, and these are the two interfering signals. But in the case of adaptive array, you can understand this concept very carefully, and this is the very important technique through which the main lobe of the radiation pattern, or we can say beam pattern, changes if the mobile user is moves from one location to another, we can say clockwise and anti-clockwise direction, and the interference signals is created uh, is null in the case of adaptive array systems. So through, or we can say during the analysis of a smart antenna, there are some benefits and there are some drawbacks. The benefits are the smart antenna systems increase the capacity of the systems, we can allocate more carriers per cell, increase the useful received signal level, lower the interfering level, significant impairments in the signal to interference ratio. This is the important in the case of smart antenna system. Reduced frequency use distance, increase of the range of the coverage. This is second important factor that we have discussed in this lecture, and it becomes more directional, most cost efficient deployment, mitigation of multipath and intersymbol interference, security is another important factor. And the drawbacks of this smart technology or smart systems are require more complicated smart antenna transceivers, Then a traditional base station transceiver requires separate transceiver chain for each of the array antenna elements and accurate real-time calibration of each of them. Very powerful digital signal processor and control system is required, more expensive than the conventional base station, require reasonable gain and needed an antenna array with several elements. So we have address some following important section, especially about the smart antenna systems, switched beam, adaptive beam, and beam forming techniques in this lecture. Hope so this lecture is beneficial for you. Thanks to everyone for watching this lecture. Thank you.